Hello everyone, good to see you. Today I'm going to talk about flatness. But before that, I'm going to mention we have 14 different symbols. These symbols can be handled in two different ways. In first category, we can have 5 groups with the name of form, profile, orientation, location, and runout. In second category, we can have 3 groups, individual features, individual or related features, related features. At the bottom of this table, we have a dimension of these symbols. If you are going to use any commercial software, they are going to follow these dimensions. Let's talk about form features. We don't need any datum reference for all of them. We may not need to use any modifier. Just whenever we are going to use flatness or straightness for mid-plane, in that situation, we may need to use modifier. Let's compare these two examples together. First, we have this table, and the height of this palette is 40 plus minus 0.1. It means the height should be changed in this interval, 0.2. This wavy surface should be in this interval. In second one, the height of this palette is 40 plus minus 0.5, and the flatness of this surface is 0.2. If I'm going to consider two parallel surfaces, this wavy surface should be in this interval, 0.2. Based on the flatness, this example and this example, they are exactly the same. However, the height of this plate can be changed between 40 plus minus 0.5. Here it is 40 plus minus 0.1. Here, the flatness is important. The height is not that much important. It is the advantage of using feature control frame. We don't need to have that much tight tolerances here. At the top it was 0. Plus minus 0.1. Here it is plus minus 0.5. Based on the application, the flatness is important. It should be 0.2. In this example, we have flatness of this surface. It is 0.25. The height of that should be in this interval. It means if I'm going to use any two parallel surfaces, the distance between these two should be 0.25. This wavy surface should be in this interval. For sure, the height should be between 17.9 18.5, and for each parallel surface, this wavy surface should be in this interval. It doesn't guarantee this surface is parallel to another surface, for example, at the bottom. Just it's going to highlight the flatness of the surface. Let's see this example. Again, we have flatness of this surface 0.1. It means the distance between two parallel surfaces should be 0.1. If the height of this plate is 30 plus minus 1, we have the flatness of this surface 0.1. The height should be in this interval. It can be between 29 and 31, and the flatness is 0.1. If it is 29, it is least material condition, and the tolerance for that it is 0.1, and it cannot go through the border because 29 is border. The lowest border is here. The highest border is 31 here, and again the tolerance zone is 0.1. It cannot go through that one. It cannot be more than 31. As you can see in the middle, the height of this plane in angle, it is between 29 and 31, and the flatness of that has a tolerance zone 0.1. Let's see this example. The flatness for whole surface is 0.3. It means I can have two parallel surfaces, and the distance between these two can be 0.3. But here we have another flatness locally. For each square with the size of 10, the flatness is 0.1, as we can see here. Today, as a last example, I'm going to talk about flatness with modifier. Let's see this example. This feature control frame, which is related to the flatness, it's not going to highlight any surfaces. It is related to dimension. It's going to highlight the midplane. As we can see in this table, the height of this plate can be changed between 10.1 to 10.5. As we can see, we can have these two parallel surfaces, and the virtual condition can be 10.9. But the height of these in each 2 points should be in this interval. The tolerance zone for midplane is 0.4. Whenever we have, for example, modifier here, it is the same example, but we add the modifier here. What happened? It means when we have the material condition, material MMC, maximum material exists on component. When we have 10.9, the distance between these two parallel planes is 10.9. We have this tolerance zone for midplane. And when we have modifier, it means we have dynamic tolerance. We can see here, if the distance between these two parallel surfaces is 10.1, the tolerance zone for midplane is 0.8. We have more tolerance zone. Now I would like to close this session, and in next session again I'm going to give you some example regarding flatness with modifier. Thank you for today. I hope you enjoyed. See you next time.